Okay, now is the part 3 about mensuration. This video will have a look some three-dimensional question. Okay, so you see that about solids, I separate that three different kinds. One is prism and cylinder. Okay, that means maybe the base is a polygon or a circle. Okay, and the second kind, pyramid or circular cone. Okay, so you can see the vertex at the top, right? And last kind, sphere and hemisphere, I group it as one kind. Okay, so let's see about volume and surface area about the solid. Prism. First is the prism. First thing you need to think about which part is the base area. Okay, for prism, that means this base area maybe is a polygon, right? Then you need to know about the base area, and this one is a uniform cross-section area. That means if you parallel to this plane and then cut it, always keep the same polygon. Okay, and between two bases, this is the height of the prism. H is the height of the prism. Okay? How about the right circular cylinder? Base is a circle, that means it's the area of a circle. So pi r square. R, that means the radius of the circle. And between these two circles, then here is the height of a cylinder. Okay, h here is the height of the cylinder. Just now prism, h is the height of a prism. Okay, so about the volume, hope you remember. How about the surface area? About the first prism, and if the base have 4 sides, then you have 4 literal faces. So how many faces for this prism? Then you know that 2 bases with 4 sides. That means total 6 faces. So first thing you need to know how to find the area of all literal faces. Check it. Here we have 4 lengths, right? That means you have 4 rectangle. Okay, and if you flatten it, then you found that this one is the lateral surface. Okay, right? And you know the height is h here, right? And how about this one? 1, 2, 3, 4, right? If you know the perimeter of a base, that means this one, then you are easily to find the area of all lateral faces, right? So use the perimeter of the base times height will be the area of all lateral faces. Lastly, plus 2 base areas. Okay, and will be the total surface area. Understand? Okay, how about cylinder? Same as you know the perimeter of the base area, okay, then you know it. If this one flatten the curved surface, then you found that this one also is a rectangle, right? And this rectangle, the length actually is the circumference of the circle. So 2 pi r times h will be the curved surface area. Lastly, total surface area, that means this one 2 pi r h plus 2 bases, that means 2 circles, 2 pi r squared. So this is the total surface area formula. Understand? Okay, so we know about the prism and also the right circular cylinder. Okay, goes on to have a look next about the pyramid and the right circular cone. First, have a look pyramid. Actually, whatever pyramid or right circular cone, we can make use of the idea of prism, and 1/3 of the formula base area times height, that means the formula of prism, 1/3 of this one will be the volume of the pyramid. Okay, so now it's base area. If this one like a square times the height, that means this one h. Okay, so 1/3 of a times h. If circular cone, that means the base area, the circle, pi r square, right? Pi r square, okay, times the height h, and then 1/3 of it, okay? So easy for you to find out the volume of circular cone, same as 1/3 base area times the height. So now you understand how to find the volume, right? How about next? Surface area. Counted how many faces besides one base, okay? You have 1, 2, 3, 4 because you have 4 sides, so you have 4 lateral faces. And if this one is a right pyramid, then all length heights will be the same. Then you'll get that there are 4 isosceles triangles. Okay, then you need to know how to find the height of this isosceles triangle. How to find this one? That means here, okay, y, okay. Then we need to use this triangle. It comes from VOB. Can you see that? VOB. So it's a right angular triangle. That means we can use the height of the pyramid and then use OB. What is OB? What is the length of OB? Actually, it's half of the size here. Okay, if this one is a square, then you can use the projection of the vertex V. That means the point O. OB will be half of the length, half of the size. So this one is x over 2. So you have OB, you have H, then you can find VB. VB, that means here the height of this isosceles triangle. So you have a base and height 1 over 2 times x times y. Then you can find one area, one triangle area. There are 4 here, so all lateral surface area, you know it, and then plus a base. Okay? How about right circular cone? Circular cone, okay, that means you need to think, do you know the area of the curved surface area? Do you know? Yeah, this one curved surface area, that means pi r l. R, that means here, L, that means this one, this length, okay? And this one actually is a theta, okay? It's a theta. L is here, okay? L is here. So pi r l can help you to find the curved surface area, okay? That means this one, okay, I maybe use this one, actually is the curved surface area, pi r l, okay? So after you know this one, just plus the base area, that means a circle. So pi r l plus pi r square, okay? Then you ask, how can we find L? Actually, we use the right angled triangle in this cone, H, R, and L, okay? Seems like here, okay? So if you know the height of the circular cone, radius of the base area, that means a circle, then you use Pythagoras theorem, you'll find the length L, okay? Okay, then what is the total surface area? Remember 2 things, okay? Okay, here you have this one and this one. So curved surface area plus base area here, okay? And one thing I want to remind you here is about this curved surface, okay? This curved surface, after flatten it, this R actually same as the circumference of the base circle, okay? Sometimes we will need to use this relation to find some unknowns. So remember, okay? Okay, last kind, about the sphere and hemisphere. This one you need to memorize, okay, about the formula of a volume, 4 over 3 pi r cube, okay, 4 over 3 pi r cube. And about the surface area is 4 pi r square, 4 pi r square, okay? And hemisphere, that means what? Half of the volume of a sphere. So 1 over 2 times 4 over 3 pi r cubed. So 2 over 3 pi r cubed. And how about the total surface area of a hemisphere? You found that besides half of the surface area of a sphere, you still have the base circle. Okay, that means the base area, you need to add it. So 4 pi r squared and then divided by 2 plus base area pi r squared. So in total, 3 pi r squared. Understand? Okay. So you found that about the volume and the surface area, remember the units, okay? Volume in cube for the area in square. So you check it. Here we have area and h height. That means 3 sides or 3 lengths times together. For the area, only 2. That means maybe like this one rectangle, length times the width, right? Or here about the circular cylinder, r square h. You see that here we'll have 3 sides times together. And how about area? R and h times together only. Here r square, yeah, again 2 sides times together. RH same as 2 sides times together. Okay, so remember for volume, there are 3 sides times together. R square h and the sphere r cube. Okay. Then about the surface area, you see that, okay, just the area, okay, that means 2 sides. For example, here, RL times together, R square times together, R square. Clear? Okay, have a look this one, about the similar solid, this relationship between the length, okay, of the solid. Actually, when we found about the volume of a solid, you need to use 3 lengths. Here, actually, R is a length, H is a length, and the sling height also is a length. Okay, if you know that they are similar, then R1 and R2, this ratio will be equals to H1 over H2. In the same time, also L1 over L2. So for 2 similar solids, their lengths will have the same ratio. Okay, whatever the radius or height or sling height, they also have the same ratio. Okay, then how about area and volume? Remember, area ratio will be equals to L1 over L2, then it takes square. Okay, if L1 over L2 takes square, that means also will be the same as R1 over R2 takes square or H1 over H2 takes square. Okay, this is the ratio of the 2 solid maybe surface area or base area. Okay, how about volume? Volume will be take cube. Okay, take cube. For example, here L1 over L2 cube, right? Okay, also equals to R1 over R2 to cube, same as equals to H1 over H2 to cube. Okay, so if they are similar, we'll have this relationship between the length, radius, or height. Then the area and the volume will have square ratios or cube of the ratios of the lengths. Okay, now we have these 3 solids. All are circular cone. However, do you know, and they are not all all similar solid. Have a look. For example, number 1 and number 2, the first and the second circular cone, are they similar? Okay. Or how about number 2 or number 3? Are they similar? How about number 1 and number 3? Are they similar? Okay, let's have a look 1 and 3 first. You see that here is R, then here is 3R. Here is H, here is 3H. So you see that, H1 over H3 equals to 1 over 3, right? R1 over R3 also 1 over 3. Then, that means what? That means the first one and the second one, not second one, sorry. The first one and the third one, they are similar solid. Okay, 1 and 3 are similar solid. How about 2 and 3? How about 2 and 3? What do you think? Let's see. You check it. H2 over H3, see? H2 over, here. H2, H3, okay? Here is 3H over 3H, that means 1 to 1, right? However, for the second R2 radius over third one, R3, 2R over 3R, that means 2 over 3, or not the same as H2 over H3. So at the end, you see that the second and the third one are not similar solid. In the same time, 1 and 2 are not similar solid, and 1, 3 also are not similar solid. Okay, so sometimes maybe given that they are similar solid, sometimes some question maybe ask you to check it. Are they similar? Then you can check the ratio between the size of the length. Okay, okay. Sometimes maybe we can check the area or volume ratios. Are they have the square of the length ratio? For volume, they have the cube of the length ratios. So you can check it and you know are they similar or not. Okay. Next video will talk about some question about the solid mensuration about the solid. Okay.